Okay students, let us continue our conversions part 3, because earlier for this question number 19 we have seen two parts earlier. For further conversions, let us continue. You are having this as 17th conversion, chlorobutane to butane. Fine. So let us see that. This is a very simple one. Chloroethane is, you can take chloroethane, CH3 CH2 Cl. This is your chloroethane. Now here it is a step up reaction. You can see you need to prepare butane, which has double the number of carbon than your chloroethane. So let us take 2 moles of chloroethane over here and let us make its reaction with sodium in the presence of dry ether. Okay, and here you will get the product directly, your alkane, which is your butane. If you remember, this reaction is called as Wood's reaction, students. This is your Wood's reaction. Fine, where your alkyl halide is made to react with sodium in the presence of dry ether. Fine, you get back your product as butane. So that is what is one step conversion. Fine, now let us look at the second one, that is another one, that is benzene to diphenyl. Fine, benzene, you are knowing that this is the structure for benzene. You see that you are doing its chlorination first. Okay, you are doing its chlorination in the presence of Cl2 plus FeCl3 minus HCl will be there. You know that electrophilic substitution reaction will be happening, and here you will get chlorobenzene as your product. First product, chlorobenzene will be formed. Here Cl plus is formed, electrophilic ion which attacks your benzene to form your chlorobenzene. Now as we have done above, let us take 2 moles of this particular chlorobenzene. Fine. So we will take 1 mole of chlorobenzene reacting with the chlorobenzene formed in the presence of your dry ether with sodium. Okay, dry ether. You will see that you are having your product referred to as diphenyl. Both of these will be combining. As here you above you have seen butane formation, here also your 2 benzene rings will be combining, and this leads to formation of your biphenyl. Again using whatever I just now about told you, Wood's reaction. Now let us go ahead with the next one, that is tertiary butyl bromide you are having to convert it into isobutyl bromide. Okay, so tertiary butyl bromide can be written like this: CH3 C CH3 CH3 and Br. As 4 carbons are there, it is butyl, and you can see that a halogenated carbon is attached with 3 methyl groups, and hence it is tertiary butyl bromide. Now when you are reacting this with alcoholic KOH, okay, or you can write ethanol and KOH, then you will see that beta elimination will be taking place. So here Br and H will be removed. So you will see that the product which you will be getting would be CH3. Here you will see that you are developing a double bond now. So you will get back CH2. So the name of this particular product is isobutylene. Okay, isobutylene. Here what you have done, you have done beta elimination, okay, or dehydrohalogenation. Now this isobutylene is then further reacted with HBr in the presence of peroxide. So you will see that Br is attaching to the doubly bonded carbon, where you are having more number of hydrogens attached to it, right? So this will have one hydrogen, and this hydrogen will have your Br. So this is your isobutyl bromide. Isobutyl bromide. Okay, fine. Now let us have a look at aniline to phenyl isocyanide. This is the last conversion. Aniline has a structure over benzene, you are having NH2. Now this is, you can directly prepare phenyl isocyanide by reacting it with CHCl3 chloroform and 3 KOH, and you see that the product is your phenyl isocyanide formed. okay, along with liberation of your 3Cl and 3 water. Now this product is your phenyl isocyanide. Students, this is one of the naming reactions, if you can recall, that is referred to as your carbalamine reaction. It is carbalamine reaction, where you can see that this particular amine group, when made to react with chloroform, gives you your foul smelling compound that is referred to as your phenyl isocyanide. They have got foul smell. Now this is one of the reaction which is helpful in determining the primary amines. Okay, so this is one step conversion. So you can just have a look the conversions all together on one page this way. I hope it is understood. Thank you.